Hello everyone. Today I will explain a math concept to you all. Called optimization using differentiation, the Chinese meaning is to optimize using differentialization. First I will explain optimization to everyone. Optimization is also called optimization. The Chinese meaning is to optimize or maximize. It is an important branch of applied mathematics. At the same time, we calculate the maximum or minimum value of a function to select an optimal element and make a plan. As for what is differentiation, the Chinese meaning of differentiation is differentialization. It is the process of seeking the derivative of a function at the same time we look for the rate of change of quantity. Everyone can go to the link below. It summarizes some basic principles in rules for finding derivatives. Everyone can go up and learn. Next I will explain to everyone how to define maximum and minimum points. There are two methods. The first method we will have a default condition. We assume the function f(x) has its first order derivative f. The first rule is, if f equals 0, then x0 represents the value x equals a certain number. We use x0 to represent it at the same time, x changes from the left of x0 to its right. And the value of f changes from a positive value to a negative value. Then we know fx0 is a maximum value. x0 is a maximum point. The second rule is, if its first order derivative equals 0. If f changes from a negative value to a positive value, then we know fx0 is a minimum value. x0 is a minimum point. We will explain it with a diagram. We can see 5 points A, B, C, D, E in the diagram. And D are located at the peaks. While B, C, D, E are located in the troughs, we can see the curve at point and point D are both positive values, gradually becoming negative values. They are maximum values, and f is a maximum value. Is a change from negative to positive. We know their minimum values, minimum points. Minimum points. The second method is, we also have an assumption. We assume the function f(x) has its second order derivative f. The first rule is, if its first order derivative equals 0, and its second order derivative is less than 0, then fx0 is a maximum value of function f(x). fx0 is a maximum point. The second rule is, when its first order derivative equals 0, and its second order derivative is greater than 0, then fx0 is a minimum value of function f(x). And fx0 is a minimum point, as for the second order derivative. In fact, it is based on the first order derivative. We can use the same differentiation rules to find the first derivative, which becomes the second order derivative. Everyone can go to the aforementioned website to learn. Next I will explain with some examples how to find maximum and minimum values, or maximum and minimum points. First we have the function, which is 3x squared minus 2x minus 3. First we find its first order derivative. We set it equal to 0. We get x equals 1/3, taking the second order derivative equals 6, which is greater than 0, referring to the principles just mentioned, is a minimum point, at this time fx. We can, by substituting x equals 1/3, into the original function, obtain this minimum value. Next is the second example. We will have another function. Similarly we will take its first order derivative. We get x equals -2. The table below summarizes the changes in the value of x. Change like this. We see when x is less than -2. When x equals 2, it is 0, between -2 and 1 it is negative. When it equals 1 it is 0. When greater than 1 it is positive. We see the function curve. While between -2 and 1, the curve is decreasing, we know x equals -2 is a maximum point we can. We obtain the function value at this time, which is the maximum. Similarly, when x is greater than 1 the derivative is increasing. We know when x equals 1 the derivative has this minimum value. X equals 1 is a minimum point. Similarly, we can see from this graph, an x equals -2. There is respectively a minimum value and a maximum value. Speaking again, About using differentiation to optimize, what are the practical uses? We usually maximize the total profit and minimize the total cost. At the same time, we conserve limited resources. For example, a farmer has 2,400 acres of farmland, thinking on one side bordering the river and only one rectangular fence. Asks, how should this rectangular fence be arranged? For example, if we have a large fence, we can see that the rectangular farmland has the maximum area. First, we know the goal is to maximize the area. We can use it to represent the area x, to represent the width, and y to represent the length. First, we establish two equations, one related to the area and one related to the perimeter. Then we can calculate the length of the area x is equal to 1000. Then we can calculate the length of the area x is equal to 1000. Then one variable at the same time we define the range of x, which is greater than or equal to 0 and less than or equal to 1000. Then we construct the first order derivative of the area equation and set it equal to 0. We know x equals 600. This is an extreme point. Substituting x equals 600 into, we get y equals 1200. Finally, we can conclude the dimensions. We can calculate the length of the area x is equal to 600 feet by 1200 feet. We can apply this method to explain another example. We can calculate the length of the area x is equal to 1000 feet by. We can calculate the length of the area x is equal to 1000 feet by. Its daily profit. Similarly, we take the first order derivative of p with respect to x and set it equal to 0. We get x equals 200. Taking the second order derivative, it equals minus 0.04, which is less than 0. We can deduce x equals 200 as a maximum value. We can calculate the length of p with respect to x and set it equal to 0.04. Finally, in summary, differentiation is in fact a very important method to help us solve some optimization problems. At the same time, it provides some strategies for us to make some beneficial choices. Finally, there are some references, and thank you all for watching my explanation.